So the final section in chapter 5 is really not a section on Newton's third law of motion, but it's kind of a summary of all three laws. So in here, I want to remind you that we are on page 5 in the purple packet. And now that we've looked at them all, we want to make certain that we've got them all straight. So one, do you have all three laws memorized? Okay. And you have them memorized in the way that we've been talking about. So the first law, the law of inertia, is an object at rest stays at rest, and an object in motion stays in motion at a constant speed in a straight line unless acted upon by an unbalanced force. Number 2, the second law of acceleration is F equals ma, or you can write it A equals F divided by m. Either way is fine. You don't need to do that in words. The third law is the law of action-reaction, and it is for every action force, there is an equal and opposite reaction force. So one thing that we do at the very end here is we look at a number of scenarios and try to determine which of the three laws are these scenarios good examples of. So you can always make the argument that all three laws are truly present for pretty much any scenario. But the point of these is that there should be one that kind of stands out. So what I'd like you to do is pause the video for a moment, read through these 10 statements, identify which of the three laws, 1, 2, or 3, and then we'll go over the answers. So for the first one, number 1, as the fuel in a rocket ignites, the force of the gas expansion and the explosion pushes out the back of the rocket and pushes the rocket forward. That sounds like number 3, the law of action-reaction. Number 2, a frog leaping upward off his lily pad is pulled downward by gravity and lands on another lily pad instead of continuing in a straight line. That sounds kind of like an unbalanced force acting upon him, which sounds like the first law. Number 3, when you are standing up in a subway train and the train suddenly stops, your body continues to go forward. That reminds me of inertia. So I'm thinking that's number 1. Number 4, after you start up your car, as you give it more gas, it goes faster. Well, that sounds like accelerating. So I would say that that would be number 2. Number 5, a pitched baseball goes faster than one that is gently thrown. Okay, that sounds like more force, different acceleration. So I would say that's number 2. Number 6, a little girl who has been pulling a sled behind her in the snow is crying because she stopped to tie on her hat and the sled kept moving and hit her in the back of the legs. Well, that sounds like inertia, so that's number 1. Number 7, when you paddle a canoe by pushing the water back, the canoe goes forward. That sounds like action-reaction, which is number 3. Number 8, as an ice skater pushes harder with his leg muscles, he begins to move faster. Oh, that sounds like acceleration, so that would be 8. Number 9, when Bobby, age 5, and his dad are skipping pebbles on the pond, the pebbles that Bobby's dad throws go farther and faster than his. So I'm thinking the dad can probably apply more force to the pebbles, so that sounds like different acceleration, so that sounds like number 2. And number 10, when you push 2 different balls across the floor, a ping pong ball and a golf ball, for example, one accelerates more than the other. So that would sound like number 10, again, the law of acceleration. Now, again, you can definitely make a case for some of these other laws for each of these scenarios, but I personally think that that's what kind of stands out with these. So you will see some of these on your test and on your final, but if you think something different, you are welcome to make that case, and I am 100% good with that. So that's what I'm thinking about for 3 laws of motion, and I am going to want to conclude with this. So there is one last video from Veritasium again, and he is going to talk about the 3 incorrect laws of motion. Now, these are things that a lot of people believe that Newton's 3 laws are about, but they are incorrect. He's not going to explain what they are or why they're incorrect. And in your comment here, when I ask you what you learned, I'd like you to think about what you thought about these 3 laws of motion before we started talking about them this year. And what do you realize now about them that maybe you didn't realize previously?
Nearly 350 years ago, Isaac Newton came up with 3 laws of motion that govern how everything moves. They're 3 pretty famous laws of motion. And they're not very complicated, but if I told them to you as clearly as I can, you would think that you're understanding them, but I think you wouldn't. And the reason is, everyone has ideas about physics and about how objects move before they're ever taught anything in a science classroom. So rather than tell you Newton's 3 laws of motion, I would like to tell you Derek's 3 incorrect laws of motion, which are the ones I think you're actually thinking. So, Derek's first incorrect law of motion is an object with no unbalanced forces acting on it will naturally come to rest. Derek's second incorrect law of motion is that an unbalanced force causes an object to move with a constant velocity. We could express this in an equation where the unbalanced force F equals the mass m times the velocity v. So, if you double the force, the velocity also doubles. It's just like being in a car. As you press on the accelerator, you increase the force on the car, and therefore you move to a new, higher constant speed. Derek's third incorrect law of motion is that larger objects apply larger forces to smaller objects. When a large truck slams into a car on a highway, the force of the truck on the car is much greater than the force of the car back on the truck. Or, if you think about the Earth and the Moon, the force with which the Earth attracts the Moon is greater than the force with which the Moon attracts the Earth. But remember, this is an incorrect law of motion.
Okay, so at this point in time, I normally ask, what did you learn? There's a lot to what we've done this year, and some of it may seem like there wasn't a ton or a lot going on, but truly, there's a lot to these 3 laws of motion that most people think are fairly simple, and you have learned a great deal about all 3 laws. So, this is the end of this chapter, and you will have either a chapter test or a little quiz, or it will be part of your final to be announced in class.